that look okay? All right. Estimate the half-life of carbon-14. Now, what does half-life mean? Well, how long it takes for half of it to decompose, right? Now, how much are we starting with? Look at your equation. What are we starting with? 20. So don't we want to know what the T is that will give us 10? Really? Isn't that what we need? So what are we going to do to solve this equation? Divide by 20. So we'll have 0.5 equals e to the negative 0.0001216t. Natural log of both sides. That's gone, so we have ln 0.5 equal negative 0.0001216t. So t equals ln 0.5 over negative 0.0001216. That should be my answer. So, let's see what I got. Somebody's back there growling. I'm not sure what it's. 0001216. How about 5,700 years? Or was that years? Yeah. About 5,700 years. Now, what I'd like you to think about here for a second is, I started with 20 because that was in my equation. That's my initial value in my equation. So, would it have been any different if instead of a 20 here, there had been an 80 there? And that would have meant I was going to 40. Would anything have changed in working it out? No, the half-life does not depend on how much you have. Now, how much you end up with, yes, does depend on how much you started with. But when you do a half-life question, sometimes they just ask you what the half-life is and they don't tell you what to start with. Start with whatever you want. Right? You're going to end up with half of it. Okay, what was the other one I needed to do? Okay, I graded these papers. I know they aren't perfect. Allie? 3.2 homework, 2B. Exponential function. So I'm shooting for a times b to the x. I've got to remember, what I'm looking for. And I know that the initial value is 2.3. So I know my equation is going to be 2.3 something to the x. And I know that I have a point, negative 2, 1.472. Allie, are you with me so far? Or have I?
Yeah.
Okay. So now, I take this at random point, and I plug it in. So 1.472 equals 2.3 b to the negative second. So let's go ahead and divide by 2.3, see what happens. I got 0.64. Now at this point, you've always got options, but you really have options here. What some kids like to do is say, okay, I've got 64 over 100, that's what this is, and it's equal to 1 over b squared. True? So then I can cross multiply. So 64b squared equals 100. B squared equals 100 over 64. So b equals 10 over 8, which is 5 over 4. Okay? So if that makes sense to you, perfect. Do it that way. Okay? There are other ways to do it that way. So my answer is y equals 2.3 times 5/4 to the x. Lane?
Can we do 2C on that side?
So the one right under it? The initial mass is 592 of something, and it's halving every 5 years. Well, I think we talked about this. I know I did with Gordon too. You have to be real careful because your gut feeling is to say, okay, 592 times it's halving, so it's going to be times by a half, so 0.5 to the x. And that's okay as long as you define x. What does your x stand for? It does not stand for how many years. It stands for the number of 5-year increments. So if you're going to write this equation, then you have to say x is the number of 5-year increments. Because this thing isn't halving every year, right? Andrew, what are you doing? I think I'm in G period. I love G period with the corner. All right. Now, I think a couple of you thought of a different way to do this problem. Did anybody modify your exponent? David?
Yeah.
What did you say?
I made it 1/5. Like the answer, I made it 1/5 x.
That's perfect. That's absolutely beautiful. Because that means that if x is 5, you would be halving once, right? And that's exactly what you want to have happen. So that is a great way to do it, David. And then in your problem, x is the number of years.
So that means that x isn't the 5 years, it's just 1 year?
Yeah. Yeah. And you don't really need a definition unless you're making this something other than every year. Normally in an exponential, that exponent means every year, every hour, every minute, whatever. So if you're going to make that something different, you have to say that. This would be fine. Okay? All right, good questions all around. What else? Anything else? On either homework you got back or your quiz that you got back? David?
Can you 3-3-1 f?
3-3-1F.
Yeah, I'm on 3-3.
Okay, 3-3's not due yet, is it?
I did it. It's coming up.
That's all right. Let's do soon. We'll do it. Now, let's look at a little simpler version of the problem. Sometimes there's so much going on that we get a little confused. Now, what if our problem were ln e to the 6th? What is that? That would be 6, because this is the log base e of e to the 6th. That is 6 log base e of e, and log base e of e is 1. So, in an expression, when you're taking ln e to a power, the answer is the power. Now, what am I doing in this problem? Wait, I'm backwards, sorry, backwards, let's go the other way. E to the ln 7, what would that answer be? 7, because this is e to the log base e of 7. That's gone, that's your answer. So when we take e to an ln something power, the answer is just the power, no matter what it is. So what's the answer to this question? 5th root of e. 5th root of e. I know there's a lot of e's going on in that problem, but only 2 of them can cancel. These 2 can cancel right here, that b, c, there, cancel.
So if we put like e to the 1/5, would that
Oh,
be
that's fine. That's fine.
But the answer would just be 1/5 if you have to have e.
Yeah, have an e in it. 1/5 if you had E ln 1/5. You see, then the answer would be 1/5. All right, anything else, you guys? All right, I'm gonna work diligently to prepare some practice material because we need to get a quiz in. We need to get a quiz in. Okay, so we're all good. All our homework questions are answered. Anna?
Can you do 2C
On
on homework grade
3.3, 2C. All right, who's got an idea? Who's got an idea here? Guys, pay attention, be respectful of your peers. You're all very smart people, you can learn from each other. Yes, ma'am.
6 divided by 3.
So she says, first thing I'd like to do is just get rid of this. That is completely legal, Brooke, completely legal. And really simplifies my problem. Because now what does it say? What's he say, Lucy-Lou? So 5 to the second equals x. So the answer is 25. Chuck?
Can you do number 3 on 3.1?
3.1. Number 3, which is assault. Yep, we sure can. This is important. This is a no calculator problem. So sometimes, some of you use the calculator. I don't want you using a calculator on this problem. I didn't tell you that, so it's okay. But make sure you know how to do it without a calculator. Because this will be on the no calculator part of our test. Sometimes, when we see x's in the numer or x's in the exponent place, we immediately think logarithm. But there's something special about 27 and 9. What's special about 27 and 9?
Write the book as 3 then.
They're both powers of 3. Now, notice I didn't say they are multiples of 3. There's a huge difference. If this number had been an 18, well, or even if this number had been an 18, you can't do anything. I mean, you need a calculator. The only time that you can do this without a calculator is if you can make them both the same base. So this is 3 cubed, and this is 3 squared. Now, I don't know if it was this class or the other class, but I had a couple people set these equal to each other. I know. I'm just sitting there thinking, what is wrong? Because you cannot set the exponents equal unless the bases match. So now they match. So now I can say 3x plus 12. Don't forget everything you learned when you were young. When you raise a power to a power, you multiply the exponents. So it's 3 to the 3x plus 12 equals negative 4x. So 7x equals negative 12, and x equals negative 12.
I don't even know what I did there.
I don't want to know what you did. Makes me even greater than I already am.
On homework 3, can you do number 2?
Huh?
On the homework 3, can you do 2D?
2D. Did you try it, Alana?
Sort of, but I got like confused and I was
Alright, so 4 on base 3 of 181 equals x. Now this kind of looks like Brooke's problem. There's this number hanging around out in front. But this time, it's going to be inconvenient to divide because there's nothing over here that's up to x. So what else could I do with this form? Kids, it's a number in front of a logarithm. And a number in front of a logarithm is a exponent. So this is going to be the log base 3 of 181 to the 4th. I'm really not interested in figuring that out. So let's loop-de-loo it. If we loop-de-loo it, we have 3 to the x equals 1 over 81 to the 4th. And what can you tell me about 1 over 81? It's 3 to the negative 4. So 3 to the x equals 3 to the negative 4 to the 4th. So what does x equal? Negative 16. All right. Now I feel like I'm just doing the homework for you. So I'm going to stop. And you can have the rest of the period to help each other do the homework.